All right, class, this video we're going to walk through writing repeating decimals as fractions. And so this first example, we're going to take 0.3 with the repeating bar on top. So we got 0.3 with the repeating bar on top, and we want to write that as a fraction. So I'm going to give you a process to do this. It can seem a little cumbersome at first, so just walk with me through it, pay attention to the examples, and we'll go from there. So why don't we start off by just using a variable. We're going to use n. Now you could use x, y, z, p, a. It doesn't matter. We're going to use n for number. And what I want you to do is we're going to lose the repeating bar, and we're just going to write down 3 decimals. Now the first thing we want to do is remember the golden rule of algebra. And the golden rule of algebra says that what I do to one side, I have to do to the other. You're going to want to remember that rule. It's going to come up throughout pre-algebra, Algebra 1 and Algebra 2 and beyond. And so what I've done here is I've multiplied the left side by 10, but if I do that, I have to multiply the right side by 10. Now think about it this way. If I'm working with an expression that says n is equal to 0.333, so 0.3 repeating, and I want to maybe move, what I'm wanting to do is move the decimal. Okay, you're going to see why I want to move the decimal one place in a moment, because this pattern repeats every digit, every place value. So here's the 10th place, and that's when it starts repeating. So that's where the 10 comes from. Now I'll come back to that in a little bit. But I don't want, so if I move the decimal here, I do that by multiplying by 10, I've got to do the same thing over here, the golden rule of algebra. What I do to one side, I have to do to the other. So let's keep going. Let's process this 10. So that's going to be 10n equals 3.333. Now you'll notice that I've added a 4th 3. I can do that because it is a repeating. And so it's just 333 forever, right? So I can do that. And hopefully you'll see why I added that 3rd 3 in just a moment. Because what I want to do next is subtract the original equation. And this is where I hope you can see it. I want to come in and subtract n equals 0.333. Now, there's a 1 here. We just don't show it. So 10n minus 1n is 9 n's. If you have 10 n's and you subtract 1 n from it, well, you've got 9 n's remaining. But look at what I've done by adding the 0.333. I've eliminated it. It's gone now. And that's why I also cap it at just 3 decimal places. You could do 4 or 5. You could probably do 2. It'd be fine. The same thing would happen. As a general rule, I'll use 3 digits. Okay? And so now they're gone. Those are going to cancel, and I'm left with 9n is equal to 3. Now again, go back to our golden rule of algebra, and we're going to do something. I'm solving for n, not 9n. So I want to get the 9n, or the 9 off of the n. I want to get the n by itself. So what happens if I divide by 9? Right, if I divide by 9, then the 9's are going to cancel. And that just leaves me with just the n right there, just the n. But what I do to one side, I have to do to the other. So I'm going to divide both sides by n. So that's going to be n is equal to 3 over 9. Now, I can reduce both 3 and 9 by its greatest common factor, which is 3. So we're going to divide both. Let's do it this way. Divide both sides by 3, and that gives me 1/3. So n is equal to 1/3, which is equal to 0.3 repeating. Those are all the same thing. All right. Now, I would contend that it's very helpful for you in your math skill set to know that things like 1/3 is equal to 0.3 repeating. 2/3 is equal to 0.6 repeating. That's going to help you a lot to already know that, because when I get here, I know this is correct. In fact, when I see an expression like this, I don't even have to go through this process. I know immediately that it's 1/3. But this would be the process of making that happen. All right, let's do another example. I know this can be a little confusing to say the very least. So let's look at, what about 0.25 repeating? 0.25 repeating. And so if we were to write this differently, that would be 0.2525. Now it does keep going, but we're going to stop there, and we're going to say n equals. Now you'll notice that in this case, here's the 10th place, and there's the 100th place. So the pattern starts after the 100th place. So instead of multiplying both sides by 10, I've got to multiply both sides by 100. All right, now that's very important. So we're going to move to 100n equal to 25.25, and I'm going to go ahead and tack one more of the pattern on there, 25. So 25.2525. Now remember, the process stays the same whether it's multiplying by 10, 100, or 1,000. And so what I'm going to do is then subtract my original equation. All right, and so 100n minus n is now 99n, and that's going to be equal to 25. I'm going to follow my golden rule of algebra, and I don't know why I wrote 25 there. I'm going to divide both sides by 99. So n is going to be equal to 25 over 99. That expression is the same thing as 0.25 repeating. Now we can prove that to ourselves if we want. We can come over here and we can divide 25 by 99. We know that goes in 0. That's going to go in 2 times. 2 times 99, what is that going to be? 198. And we're going to subtract that, and that's going to give us 52. We're going to drop the 0, and look what happens. It's going to go in 5 times. Now, if you keep going through this and keep working through the long division process, you will see that pattern begin to repeat. 0.25, 0.25, 0.25. All right? Let's do one more example. What if we have a whole number plus a decimal? So we've got 1.45. Well, what I'm going to encourage you to do is disregard the 1 for just a moment. And let's just say n is equal to 0.4545. We're going to multiply both sides by 100 because we've got 2 decimal places there. So we're going to multiply both sides by 100. And that's going to be 100n is equal to 45.4545. I'm going to subtract my original equation. Hopefully this pattern is starting to make sense to you by now. That's 99n is equal to 45. Divide everything by 99 because remember, I'm wanting to separate that. I'm wanting those 99s to cancel. So that's going to give me n equals 45 divided by 99. But as I look at that, I know my multiplication facts, don't I? And I know 45 and 99 are both divisible by 9. So 45 divided by 9, what is that? 5, right? 99 divided by 9 is 11. So we have 0.45 repeating is the same as 5 over 11. So what's my answer? 1 and 5 over 11. I've got to go back and pick up the 1. Let's check ourselves. What if we divide 5 by 11? All right, that's going to go in 4 times. There's 44. We're going to 6, drop our 0. That's going to go 5 times. 55, and you're beginning to see maybe a pattern here. Okay, it goes back into 4, and you can see the pattern beginning to form at that point. So we're going to have 0.45 repeating. All right, listen, I know this stuff is a little crazy, but just take some time with it. Keep working through these examples. Keep watching these videos, and it's going to make some sense. I promise you that.